How's it going, everyone? Eulio Gonzalez here again, and in today's video we're going to talk about is the React in Typescript and how can we make type or components as a way to make sure that we're getting the property that we need to and debug our applications without leaving the editor. That's the goal of this series of videos, especially in this course, which is taught by Steve Kinney. He is now the front-end architecture at Temporal, which is a very interesting tool that allows you is to make sure the execution of your applications work when a system fail. So it can now replicate or it can run into a different computer. Again, something that I am still figuring out what in the French toast that means, but in the meantime, yes, this is the goal of this course, and the goal of this series of videos is as a way to improve my technical communication skills when I need to be precise and explain complex idea to make it meaningful to others, so I can empowering is a team along the way. So the things that we're gonna now learn here is that, okay, learn how to use your editor to find types in components inside of your Visual Studio Code, and as well as learn to use the context API, React hooks, and type props in your React application. Something that we barely use, for example, the context API, and something that a lot of companies are actually asking as a way to say, hey, do you know this? Do you truly know this? And then React hooks, something that I'm quite familiar with, as well as the type props. So this is now the fundamentals. Whoever is now on the software engineer, specifically on the front end, that must know. It's like, hey, do you know how to type these components? Do you know what is the value proposition of typing components, as well as how you can use the context API, the React hooks as the type props in your components. 3 components, part of the anatomy of your React component. All right, the context API as a way to store is the app level data, and when you change anything on the context API, it will re-render across that. The other is the React hooks, as well as the type props. So this course is just laid out in this way. We're talking about is the introduction, something that we did yesterday. We're gonna make a quick recap about that. Components, API, typings and refactoring, and then genetics. So the idea is that by the end of this video, or by the end of this video, we wrap up about the components. We get is the value proposition out of this, the pills, the nutrition pills out of this, so we can move on to the next one. So the introduction here is just as a way to cover, in this course, is to cover 2 things. It's a philosophical aspect of the Typescript, as well as that you don't need to usually leave the Visual Studio Code, because the answer is in there. So that's one of the things that by looking at the code hints, or by following the hints in your code editor, okay? So by follow the hints in your code editor and doing some code introspections, a lot of the time that's the best way to figuring out the path for. And I stick to this. And I stick to this. Why is that? Because in my experience, exactly, it's usually that you follow the code hints, usually because Typescript can be finicky about it, so you don't know if there is a type error or is Typescript just being finicky about it, okay? But the idea here is that by looking at the hints provided by your code editors and in doing so code introspections, a lot of the time that's the best way to figuring out the path for. So instead of jumping into the web browsers, you can just check that without leaving the editor. So we're going to learn TypeScript in React as we build, which is learning through doing. And we'll learn enough to keep up dangerous and then some advanced pattern. All right, now this is the TypeScript pitch, the sales pitch, a brief sales pitch of TypeScript. First, because crashing things on build time is way much better than doing at runtimes or getting unexpected behavior at runtime when your users are consuming your app. You definitely don't want that. And since we're working with teams, and sometimes we make errors, so to prevent that, well, for example, you are not at your full, you're not at 100%. After all, we are humans. So to prevent that, well, TypeScript, okay, complains about it, about, hey, this is something that you should check. So error at build time, not at runtime. The other is the autocomplete, which is increase the user experience, increase the developer experience. So by sometimes you want to now have access, or let's say you sometimes misspelling some actions in. Sorry. Sometimes you might, for example, misspell a reducer actions. So that's when it came handy. So for example, reduce. Again, that comes handy to actually say, all right, is this one. The autocomplete. And the other is that your code base are much more easy to maintain. Your code base are much more easy to maintain and stable because you have all of these guardrails on how your code can be used. This is more like the technical communication, and especially when you need to talk to someone in an interview or in any place, it's like that. It's like, oh, that makes sense. It's like, oh, that's what it is. All right? That's the brief sales pitch. It's like getting errors at runtimes, getting errors at build time, not at runtime. The autocomplete feature, which is something useful, especially, for example, let's misspell a reducer action, so it prevents you to do that. And the other is for organization, the organizational aspect. Let your code base stay maintainable, because now you have a lot of these guardrails on how your code can be used. And I really love this. So then we look now at the component features. And also another interesting here of TypeScript is that as TypeScript release new features and drops some of them, it becomes much more useful and requires less ceremony to do two types of components. So that's quite interesting. So it required less ceremony in favor of dropping all features. So now we look at the components here. So first thing first, we look at hey, how can we now how is a React component with TypeScript? And the thing here is that, well, you transform that into from JSX to TSX. Of course, you need to lay out is the setup for that, and that is, well, your project must support is TypeScript. You must install TypeScript. By doing that, you say, hey, let's going to install is the compiler, then TypeScript, okay, and provide is several of the configurations here. For example, like this. Hey, I want you to allow JSX. This is all part of the compiler options that you're gonna find in Create React App, or in Create React App. One of the things that are useful for is the ES model interoperability. Right now, actually, this is and it will become less and less quite useful because as we are codebase evolve to ES6 models, that'll be better. Allow synthetic default imports as a way to hey please allow me to add this outer import for me. The strict as a way to prevent any as a type, and this is now to help us is with the GSX syntax. Hey, I want you to highlight this syntax for me. So that's exactly what we did. So we transform all React components into TSX, okay? And we look at the features and the benefit that allow us when we define is these type props. And that's exactly what we're gonna do today, right? Which is, hey, refactoring from prop types an exercise. So it's telling us change the file extension from GSS to TSX. That's right, we did that. Get rid of those gnarly prop types and add types to our props. You can either do it or you can create a new type called control panel props. Okay, and it's funny because it called this as a type. So let's do it. Let's do it. You're gonna call this the control panel props here. Control panel props here. Okay. Right now you're gonna follow me along here in the code base. Let me actually make it much more readable. What in the F? There you got it. So here we're going to define is this control panel props. Okay, as a type, control panel props that it will have is this. So this type control panel props will have now, for example, is the name, which will be a string, as well as this on change, which we say, hey, this will be a function, right? And when we attach that to this, all right, when we say, hey, you know what, this object that we're receiving is a control panel props. But it's interesting because now Typescript is telling you, hey, no, why not? Type function, this type that you're assigning is not assignable to a change event handler. Type function provide no match for the signature on the event change event HTML input, which means is that the function here is not a function. In fact, is a change event handler. So it expects to be a change event handler. So it's also important to recognize is the terminology that they're using. You know, the change event handler. So if we take a look now at here, okay, which is this change event handler, as you can see here, is a type genetic, okay, where now this event handler is a synthetic event, meaning it's a wrapper around this change event. And you may wonder, hey, what is a change event? Well, change event extends or can have access to the property method from the synthetic event. You know what I mean? Which can be of any shape, of any type, but that type must be an element, and that must contain is a target for that. So if we take a look at the synthetic event, it say, hey, we actually now are accessing to the base. As we can see here, we're actually reading its React code. You know, we are getting into this React code, especially the types, and say, oh, this synthetic event is now access to the base synthetic event, where it receives the element, the event target, okay, or another parameter, as well as the event target. So this base event, which is base synthetic event, is like, give me the element, give me the event target, okay, and give me another event target. So base synthetic is now a wrapper around this. You know, base synthetic is that this is an object, this is another object, to do change any unknown event system, to do change any unknown when moving to Typescript version 3. And it's funny because this is how they define this base synthetic event, which is, it followed this particular signature, native event, like this, current target, and the target. That's quite interesting. Give me this element, and then I got the current target, what I'm going to apply, what I'm going to listen to, and the target. Bubbles, cancelable, default prevent, event phase is trust. But as we can see here, we are now is from all of that, here we are passing is a change event handler. And this event handler implement is this. You know, this event handler implement is this. So this is the shape of this event handler. What is accepting here? It actually has, it is data, as well as it is method that is exposed. Stop propagation is propagating stop, persist and prevent default. That's quite interesting. Why is that? Current target, a reference to the element which the event listener is registered. Because now this is the wrapper that React create as a way to have access, to provide you access when these elements get rendered. In this case, when the control panel is rendered. It's like, I accept is this. Change event handler. So with that, when we save that, all right, we say, hey, npm star, because we're using this to create a React app. There you got it. File successfully emitted, waiting, no issue found. Issue checking in progress, no issue found. So we don't have any error with Typescript, okay, which is great. All right, we did it. What's next? See if you can add another property to the name badge called greetings. This process should replace hello on the badge. Okay. Let's go to attach is another property here. Call is the greeting. Okay, which is a string. That will replace is the hello. That will replace is the hello. Oh, in name batch, exactly. It's not here. It's here. That will replace is the hello. Let me find is defined here. Type name batch props. Okay, and this is it. This is a name, which is in a string, as well as a greeting. Okay. This should replace hello on the badge, exactly. That'll be is a string as well. when we put this name batch props here, okay, then we can say, all right, name, we expect to get the name as well as the greeting. And greeting will be replaced here by hello. So greeting. All right. But you say, hey, I'm expecting is to get an error. I'm expecting you to provide me is this property on the application. And we say, well, let's gonna do that. In fact, here we're gonna say is that follow the exercise. And apply what we're going to learn. Which is, so follow the hint on the Visual Studio or your code editor. Follow the hint of the code editor and follow the hints of follow the hint in code editor and do code introspection. This and this one, and do code introspection introspection. Okay, follow the hints of the code editor and do code introspections. And do code introspection. That a lot of the time it is a better way, we can say here. Okay. It's a lot of the time is the best way to figuring out. That a lot of the time it is the best way to figure it out, the path for. To figuring out the path for. Okay? Follow the hints from the code editors and do some code introspections. But a lot of the time, that's the best way of how you figuring out the path for. Pretty simple. Pretty simple. And here we have to pass is the greeting property and say, hey, this is hello. Can you see? Yeah, that's right. And then you get it. It's like, hey, this is it. No problem. Webpack saying, hey, good. Good, you're doing good. What is the next thing I need to add? See if you can figuring out how to type the onChange handler. Hints. Use what you have learned to hovering our property to figuring out that. And if you want to clone that, here. Let me take a look at what is the solution from them. Exactly. What is this? Change event handler on an HTML input. But it is interesting because it say, hey, this is a change event handler of anything. But this is an HTML element. Exactly. This is a change HTML element. For readability, we're going to put it in this way. Okay, let's get into this.
We're changing the file extension from JSX to TSX. We're going to take those to kind of like, I'm getting, like everything mostly works except for the fact that like it didn't acquiesce that these prop types were real types. So the convention, and I like conventions because I don't want to come up with my own, right? And also, like, one of the hard problems in computer science is naming things. So what you will normally see, what is, I don't know who made this rule, but the standard convention is you can type it inline, or you can make a new type, which is what we're going to do. And a lot of times for React components, you would call it control panel.
Exactly. So the convention here is this. So now this is the solution. The convention is to put the props type like this in the name or in the control.ts. In the control, but this is in plural. Okay, in the controls.tsx file, which is this. That's the convention. So that's the convention.
Props. That would be the type of the props pass control panel, right? And we'll start out by saying that we know the name is a string, and let's just say that onChange for a hot minute is any. Now, one of the things I want to say early now, which is if you ever feel tempted to use any, you should avoid that. Any is infectious. Like, when you have anything that any are like the setup exercises, and we will try to eradicate them over our time together. So we'll save that. And then all you have to do at this point, if you didn't like that like set of curly braces in the other one, you just do control panel props. And this is now like officially a TypeScript component. It has some extra stuff I don't need, like this. This isn't doing anyone any favors anymore, which means I don't need this. And that, you know, for a very simple component, which, you know, if you think about your app, like it's a few complicated pieces, and then like the way the satellites are around the Earth, like a satellite of like smaller pieces, right? We can have this kind of in place, which leads us to our next challenge, which is what do we do about onChange here? And so my challenge to you, yeah, got it. Sure.
Change event handler HTML and L.
Let's hover over that, and yeah, we can see that, you know, the default type of an onChange. So what do we do about our onChange? Well, we look at what React did to the default element, and we steal that, right? So it's saying like, oh, like an input element onChange is this type React change event handler on an HTML input element or undefined. Yoink. Copy. Paste. Boom. Right? We just used our editor to figure out what the type should be on that one. Right? And so a lot of times, if I'm like, oh, I don't know what a form should be, you can mostly kind of, I'll make the element and I'll figure it out. Mark.
Is there a reason why we are using type over interface here? Is it a different use case?
Yes, I am spiritually prepared for this question. One moment, please. So the question was, why are we using type instead of interface? And so, you know, a while back, there was a lot more of a difference between a type and an interface. In modern versions of TypeScript, there are less differences between types and interfaces. An interface is kind of like a class where you can extend it and kind of override individual properties. A type is a little bit more constrained, but you can kind of use it with what we'll see later are like generics or type variables, a little bit easier when you're combining stuff together. You know, if one were to Google this, you would find probably, I would say 80% of this advice saying that for public-facing things, we want someone to be able to extend it, to be able to like, you know, pull it forward using interfaces for like public libraries, but for internal stuff using types. You will also find some arguing the opposite. It doesn't matter so much, generally speaking, my heuristic then, given the like private-public kind of piece and extending versus like using unions and intersections, which we'll see in a little bit. I tend to use types unless I explicitly need an interface. There's little places where we're combining two types that have an overriding property where it can become a little tricky, and then I'll grab for an interface, but like my heuristic is to use types. However, if I were to like go to somebody else, you know, join a new team, and in their application they're using interfaces everywhere, you know what I start using? Interfaces, right? Yeah.
Sorry, what exactly is an interface?
So interface, if I wanted to change this type from a type to an interface, I would change this word to interface. I'd get rid of that equal sign. No red squigglies, right? The difference is if I wanted to like, I could say interface.
Extend.
Admin only, I can do this extends. Yeah, and I could say like, so it's got all the other properties, but I could also say like, right, so now this has name, which is a string, onChange with an event handler, and isAdmin has to be set to true, right? If I wanted to do this with types, it would be like,
admin control and the admin as it is.
like that.
And I think this is something crucial, especially if you're going to actually do that. Because, okay, that's a very good and interesting point here. Oh my God. Okay. Question. No. It's like question. Okay. Questions. Facts. No. Or Q&A. No. Q&A. And you say, all right. Wait, what the hell is this? Oh, okay, I got it. Okay, so facts. So facts or question and answer, Q&A. Why? And I think this is a very good. Why types versus interface? Okay. Types versus interface. Types is a little bit. In fact, let me actually look at the what he has to mention here. You're gonna follow me along with this because I think this is one of the core aspects when you're writing is your application. And I didn't know that. Okay. And even if we take a look now at the types here, at the types Typescript handbook, switch to tab. No, but this is not Typescript. Okay. And when we look at the handbook here of Typescript, as a way to say, all right, in the basics, everyday types, type annotation on variables, object union types, and that kind of thing. And let me see, is that narrowing with type guards? Exactly. Something as they call narrowing, which is fairly interesting. Function types and generic functions, but this is more on functions. Classes, okay. Classes heritage, member visibility, static membership, generic classes. This at runtime in class, this type, parameter property, and class. Class inheritance, exactly. Implement and extend. Implement clause. You can use implement clause to check that a class satisfies a particular interface. Hey, is this satisfy this particular interface? Good. Or the other is that, hey, I want now to have access to the property and methods from this base class. And method of this base class can also define like this. So with the extent you telling to this new object, hey, I want you to have access to this property methods. Whereas with implement, is say, hey, do you get this property that I need? Do you have this signature? Okay. So that's quite interesting, especially when you say is interfaces. Okay. Especially when we use is interfaces. Let me see, is that actually here, for example, in models, in reference here, utility types. This is utility type cheat sheet, flow control analysis, interface, types, class. All right. Used to describe the shape of an object and can be extended by others. Almost everything in JavaScript is an object. An interface is built to match their runtime. And when you got types, is this full name is type alias and are used to provide names to type literal. Support more rich type system features than interface. Exact. Support more rich type system features than interface. Type versus interface. Interface can only describe object shapes. Interface can be extended by declaring it multiple times. In performance critical types, interface comparison checks can be faster. In performance critical types interface comparison checks can be faster. Critical types interface comparison checks can be faster. Think of type like variables, build with utility types. And I think this is something quite interesting here. Map type. Why this is important to understand this first definition here. When you get the class, which is introducing the EX26 or EX6 in JavaScript, the class, and I know how the class works behind the scenes with the extend keyword, which is allow you to have access to property and methods through the prototype change, and that is that the extend set the prototype of that object to points to the base function constructor prototype as a way to have access to the methods, and then points the proto of this new object to the function constructor. So when you use this keyword super, all right, now you override that behavior. Let's put a test. Let's put a test if I don't lose my mind. So because here we're going to create now is a class for a user, a place in a user on a game. Okay, so we say, hey, user creator here, because we're creating as a class, we use this is the body of the class. First we define is the constructor here as a way to say, hey, this is the name and this is the score. Okay, because the way how now JavaScript build objects using the class and the prototype nature, it tells you, hey, you must have a constructor, a function constructor that initially I'm going to build that. I'm going to set the value of this as an empty object, okay, where you can now add properties to that, like name, okay, followed by the score, okay. And because now I'm going to create this object, I'm going to now set the prototype of these objects to point to the, all right, and we're going to set is the proto of these objects to have access to the prototype function portion of the class, because after all, class are a special type of object. a special type of functions. They're not hosted, and whatever you define in the body that is outside of the constructor, for example, methods like, hey, increase or increment score, okay. Here, behind the scenes, all of these methods will be put under the prototype portion of the class function object. So here's when we can have access to the proper reference or to the proper instance with the value of this and do something that we need to with the score. That's great. We can also define is the login. For example, if a user now wants to log into again, you say, hey, I just want to show off is the login here. Hey, you're logging. So when I use now when I want to create a new user, let's say user 1, okay, by using the new keyword under the, well, this is a convention that must be uppercase the first letter, user creator, okay, when you pass is the, hey, it's now Alice, okay, as well as Bob, okay, and then we say, hey, I want now to increment score. So what is doing this behind the scenes with the new keyword is to say, hey, let me now, as we do that, let me now build this object pretty much like we did with the prototype nature. And with the prototype nature, you define as a function constructor, and you define all of your methods inside of the prototype portion of the function. Okay, so class is now automating that process for us, okay, and it's now look like much more cleaner. So we can now, after we create this object, okay, which is after we run this function, the new keyword say, hey, do you have a constructor? Yes, let me now set this value as an empty object, all right, that you can add all of this property, and then define the dunder to the prototype of this function, of this class function object, which is a user creator. And that's quite compelling, because after that it's going to now return this new object. What you can now is actually, well, do this. So this is a more cleaner version of how you can now create objects here. Because before, the way to create object is by defining is a function, for example, user creator, okay, that you're gonna receive is the parameters as score, that the new keyword we're going to evaluate is that the new keyword we're going to create is this. We're going to set the value of this as an empty object, that you can add all of these property and methods. This dot score here, okay, and then under the prototype portion user of that, exactly under the prototype property of the user creator function, because after all, functions contain is properties like the length, arcs, and also have this property called prototype, okay, whereas here when you define prototype is you define is your increment score, for example, your functionalities, okay, as a way to do this. And then you say, hey, okay, now let me access to the current instance and then do something about it. And then you say, okay, I want you to define is another functionality. Look at how lengthy it becomes as a way to do this, like login. And then you define this function again, and you say, all right, so now I want you to is logging here, console log this, you know. And last but not least is when you define your new user, say user2, with the new keyword, and say user creator of Bob. I think Bob, yeah, Bob, and with the score of 5. We actually made a mistake here. That's one of the reasons why Typescript is important here. And then we say, hey, I want you to user.increment increment score. Okay, I want to know what is my current score of this user of Bob, and then get into the game, log in. So by doing this, you have now this. Okay, I return is this. Exactly, I need to access to the user's core.6. But as you can see here, now it will make much more sense of how now this intrinsic nature actually works. And I'm showing you this as a way to see how the inheritance or the prototype nature as a way to have access to property and method actually works behind the scenes. And how now in the context of Typescript, it's all right, the subtle difference between the types and the interface is that interfaces are more aligned. The interface is used to describe the shape of an object. All right. And if you find code bases that use interface, stick to that. All right. Almost everything in JavaScript is an object, and an interface is built to match the runtime. And the type, okay, is that interface can only be described object shapes. Interface can be extended by declaring it multiple times. So with interface, it behaves pretty much like the way of how you can. So with interface is that pretty much like you work with. Yeah, but what is the difference between the interface and the type? That's a very, very good question. That's a very, very good question. And that's the reason why we are here, to look at that, to answer that question. Okay, type versus interface. Interface are commonly used to define the shape of an object in classes. You might, however, just want to define a type of functions or type alias. Types are called too. So this is now how you can define it. Interface can extend it. Yes. Classes can implement it. You can implement with types with classes. Classes can implement, no, and can be augmented, can be recursive in some cases. So use interface for public APIs since the consumer can extend them if needed. Consider using type for your React component prop and state for consistency and because it's more constrained. The TLDR, you can extend interface. This is convenient bit, but it also can make things more complicated. It is up to you to decide if this is a thing that makes your life better or not. Here's a fun chart to look at it. Type versus interface. Okay. So, but again, the subtle difference between types and interface, at least in the practical sense, is that interface are used for public APIs. Let the implement interface so that the users can extend if they need. But consider to use types in your React components because it is more constrained. I really love this. Okay. For public, and we're talking about is the use cases. So for public APIs here, okay. So for public APIs, like it is, and I really love this different. Okay. Okay. Makes a lot of sense. Okay. All right. And this is part of the and this is a very interesting question to ask. To say, hey, do you really know this? Do you care about this? For public APIs, use interface. Okay. So for public APIs, use interface so they can extend the functionality. Okay, so for public API, use interface since consumer can extend its functionality. Can extend if needed. Can extend if needed. If needed, can extend can extend its functionality if it's needed. Okay, makes sense. The types versus interface. So far, so good. So this is for interface, right? Interface. But after all, because one of the things of React is that first, it allows us to render its specific component. Okay, it allows us to render its component. That's the whole goal of React. Render components. And the other is when we integrate that with Typescript, we want to this component behave as it is expected, that it receive. So we make sure that it receive the props as expected, and we don't need to leave the co-editors to debug our code by putting all of these guardrails in our code. So because of that, the subtle difference between types and interface is that types consider use types. Okay, types. So consider use types. Okay. Yep. So consider use types in your codebase. All right. So consider use types. So consider use type in your exactly. So consider use type here. Okay. So consider use type in your React component, since they provide much. Okay. In your React component, props and state. But it's not only for consistency, it's because it's more constrained. Consider use type in your React component, states, props and states. Okay. For public API, use interface since consumers can extend its functionality. Exactly, can extend its functionality if it's needed. Consider use types in your React components, props and state for consistency. For consistency, not only for consistency. but for consistency, but because it's more constrained, but because it is more constrained, okay, and you have much more certainty of what's going on. So for example, here, and now when we take a look at the example here, by saying, all right, okay, so by looking at this, exactly. So by looking at this, so for example, with interface, you can say, hey, this is user. You can say user. Okay. And here you have his name, and this is a string, and the score. Okay. Pretty much like this. It's a number. So if you want to create now is a base user or a subclass user, a user that can now access to this property or methods, you can also define it something like this. Say, hey, this is the login, right? And this is now a function. I return null, okay? And you know, and then you can say is like, hey, this is now paid user extend, so you can have access to the property and methods from this base class from the user. All right, and here you can say, hey, this is now balance, like a number, right? So this is just describing is how the subtle difference between them. Oh my God. No. The subtle difference between them. And when you use type, for example, with types, well, instead of doing this, you say, hey, this is now a type of user, type user, okay, where now this will be is the name, string, and yeah, the name string, the score is a number, the login as a function here. It's not going to, it's not return anything here. And if you want to define is now a subtype of this, you'll have to do is something like this. So paid user, you say, hey, this is now user, and this is the other property that it needs to. Okay. So for example, or that it has to balance, and string, I mean it's a number. Okay, so that's the subtle difference between them, especially when you define them. Holy moly, holy moly, Jesus. Oh my God, that was quite illustrative. It was quite enlightening. It's quite enlightening.
Right.
So, would you need to explain? Okay. All right. So in this A syntax is part of the type here as a way to say, hey, this is primitive, object literal, tuple, union type, intersection, type index, type from values, type from func return, type or models, conditional types. No, wait, what? Template unions, exactly. Map types, but we are working is with insert intersection type, a way to merge or extend types. By doing is this. type indexes. As you get familiar with this, and the more you are familiar with this particular TypeScript cheat sheet, you will now understand more and more how to do this. Well, alright, anyway. Alright. And the subtle difference between the type and the interface. If you find a code base that is using interface, stick to that. Or types, stick to that. Okay? But, again, for interface, use that when you need to provide a public API so your consumers can extend if they need to. Extend functionality if they need to. For types, consider to use that in React components because now you have much more constraint about it, certainty, especially when using is a props type and state. That's quite interesting. That's very, very illustrative.
So they both get me the same effect. It's usually when like these have overlapping properties or stuff like that. Stuff gets a little bit different, like in the actual implementations. But generally speaking, like these do function the same thing. So my rule of thumb. So the question was, do I always leave them in this file, or do I put them into a like a globally available definition file? The answer to that question, that either or question, is yes. Right? Generally speaking, because if I put them into a d.ts file, and like I think I have an empty one sitting over here, like any types that I put into this file, and later examples will have stuff in here, mostly because I don't want to like clutter stuff up. But in a larger app, like I will usually put like the very, very commonly used like models, right? So like the thing I work on has workflows, and workflows have events, and those are used all over the place. It's like whatever the core like things that your app is showing, right? Like if it was Twitter tweets, right? Like those types I'm using everywhere. I don't want to import those constantly, right? So I will move them into this file. That said, I personally, and this is definitely like a subjective opinion thing, tend to start them out in the file because like I don't need to be littering the global namespace with all these types that are only ever actually getting used in one file. So normally, a lot of my types will start out in a file, and when I find myself getting very annoyed importing them places, I will begin to break them out and move them into definition files. So it's usually a refactor for me at some point. Tend to start them out in the file because like I don't need to be littering the global namespace.
Okay. So for example, file definition. All right, that's interesting. That's
Like I will usually put like the very, very common.
okay. But again, it's up to the. That's another valid question here. Types versus interface. The other is where to put your types. Okay, where to put your types. Depend on the project. It can be at file first, then into a at file first, then into component. At file first, then into a definition file. All right. Yep, pretty much.
Use like models, right? So like the thing I work on has workflows, and workflows have events, and those are used all over the place. Like whatever the core like things that your app is showing, right? Like if it was Twitter tweets, right? Like those types I'm using everywhere. I don't want to import those constantly, right? So I will move them into this file. That said, I personally, and this is definitely like a subjective opinion thing, tend to start them out in the file because like I don't need to be littering the global namespace with all these types that are only ever actually getting used in one file. So normally, a lot of my types will start out the file, and when I find myself getting very annoyed importing them places, I'll be able to break them out and move them into definition files. So it's usually a refactor.
If I recall correctly, another difference is type you can import TypeScript instead, right? So
yep.
how come we don't use it?
Yeah, I don't think so. Like it's one one of those things where since I predominantly use types, especially for that, like for primitives, I would like a straight, like I think about like for very simple things, like a type makes total sense because yeah, you can like say this one or that one. There's really interesting things you can do with unions. It's like they have an overlap of about like 60 or 80%. Like there's a chart that I have a broken link to real fix that shows like most of the checkboxes are green on most of them, with like one or two little kind of like smaller edge cases across both. I think the more important thing is like consistency in your code base. I choose to use types, but like I said, like they have certain limitations in some edge cases. Interfaces are gonna have certain limitations in the other one. I think consistency is probably the answer, but like there's not necessarily like this is right and this is wrong, despite what blog posts on the internet will tell you. I've been in code bases that do both. So. Cool. Okay, so we've got on change handle, again, if I needed to know what a form element was, oh look, it's a form event handler. There are a bunch of these. I have a link in the notes, like we can just see all of them, but like generally speaking, I do want to encourage you, rather than looking at the list, to kind of like, our habit is going to be, right, stuff along those lines. So it's basically trying to figure out, oh, this is a lot of times a lot easier, about as forceful as it needs to be, and no more than that, like until you try to use it. And we'll actually see that in another example, I believe, later on too. But yeah, you could have done like, event is even like HTML. Yeah, like you can see that if I was inlining it in here, and have I taken this to its natural conclusion before breaking it out? Of course I have, right? But you can see that trying to both have the properties in here and then also define the types, it gets ridiculous, right? And then if I ever do need to export that out somewhere, guess what I end up with? So for me, normally my workflow is every part of me wants to do it inline, and most parts of me know that I will regret it. And then so if I am like, if it's early in the day and my willpower and I can resist the marshmallow on the table, I will break it out into a type. Later in the day, things get a little bit fast and loose. And then I make poor choices and inline it, but then I always eventually have to like pull it out, on a long enough time. If it's just like one argument and you don't want it to do all that extra work, yeah, sure, put it in there. But generally speaking, I will try to break it out to a type.
Mm-hmm.
And I also want to change this back. I want to change all of the things I was just talking and typing at the same time. Nice part
Pushing
is,
event handler.
grab it from here. If I hit tab, I can auto import it from React. Yeah, I was hoping the auto import was going to pull it in. I guess direct import it. Auto import, so let's say React. Cool. All right, so that's back where I want it to be. Pull this out too. Let's go ahead and immediately regret previous mistakes here. Like, if it's something that matters, like strings, like.
And then now it is time to, exactly, another convention. Where to put your types? At first, in how to write your types. Inline. How to write your type inline, period. And that is, take a look at now this convention, all right? And now, in our name batch, we define that as a type as it is, and put this here. Makes sense.
String a lot of times, no big deal. But if I'm trying to
Or capture or some sort of like instead of just using it as a true locating that thing somebody specific has a small stuff that's
Yep.
that it's available, but just because it's a small
Yep.
thing.
Yeah, and we'll know that you can't pass a null. Like if I try to pass a null in here, I get yelled at, right? It's like, yo, string or undefined. No zeros, no falses, right? Like string or undefined. Undefined can be falsy, and that can be our check.
Exactly, because you have put a lot of this guardrail.
We'll actually see this kind of like, I'm
for
going to
it.
point out now so I can see if we're already like mentally aware of it. But yeah, now I can pass this in. I can say like, and you gotta pass it to props too. Look at that autocomplete. Yes. Right. In this case, like, I don't get yelled at because like passing an empty string into an HTML element is fine, right? Or undefined coerces into an empty string in this case. So that's totally okay. But if I try to use it for some other value, we will get yelled at. But you'll see that like as I was starting to use this component, especially if you're making like, this is all in the file. If I was then using this component somewhere else, I implicitly have documentation on this component, right? Like I can't really use it wrong. Try me. But it is harder to use it wrong. How about that?
Try me.
So props are fun. There is one other kind of situation that we didn't really talk about, which I'm going to challenge you with. Which is, so we got props. Some of them can be static values. Some of them can be objects. or arrays, and we'll see those over time. We saw what to do with an event handler. There's one more other like common prop, right? Like I have a list of all the other props you have to use as well, but like there's one that you might.
Typing component children exercise.
What do you do about children? Like that is usually the first like TypeScript's going great in React. I love this. I'm never writing JavaScript again. And the first time you need to like type, be like that's another React component. You're like, oh, I think I'm just gonna write JavaScript. So what I have for you is kind of a little playground and.
Okay, typing component children. Okay. So typing component children. Typing component children. Okay. Good. Perfect. Typing component children.
In here we've got, it's a repo security setting, but we have
Typing component children exercise. Typing component children exercise. Because the first was to first look at type components exercise, and then typing component children exercise.
One where it's one child is a string, because children of an HTML element could be a string, nothing, another HTML element, right? It's a repo deleting code, my security setting, turning off syntax highlighting.
Microsoft Edge. What?
In Edge. But we have one where it's one child is kind of a little playground, and in here we've got it's a repo deleting code, but like my security setting, turning off syntax highlighting in Edge. But we have one where it's one child that's a string, because children of an HTML element could be a string, nothing, another HTML element, right? A bunch of stuff, right? Like, and so we need to like kind of figure that out. And so right now this isn't any. And your job is, here are a bunch of options that I thought seemed plausible at looking at React's types. What I would challenge you to do is try these out, see where the red squigglies come to haunt you, right? And when you have the wrong answer, a red squiggly will let you know, because most of the cases are covered at the end. And we will figure out what the correct type of a child approach. Right. Spend 5 minutes, and we can do that.
All right.
We'll look at the answer.
All right. It's like good. Type versus interface. And let's go into now this one. The component children. Okay, so the idea here is to follow the exercise here. So follow the exercise. Yeah, follow the exercise and figure it out to get rid of the any value or the any type. It's not a value, it's a type. All right. From this. But I would like to make this like this. All right. As it is. Really? There you got it. This is it. All right. Cool. Under this component. All right. So let's get into this. This is on what? Yeah, but where? Oh, this is the application and on the box. Oh. Okay, use a sandbox. For that. Okay. The sandbox. Is like this. Get rid of the any here. Can I? Nope. Anyway, man. Okay, you're quite annoying. But this is on which one? Create React element. Type in children. Is this another part of the repo here? Playground link can be found. Yeah, but it doesn't allow me to edit this one. Okay. Find a workaround, bro. Find a workaround, and that is by replacing is this one. Yeah. But this is box prop. But box props is say that this is a children. A children. But this box prop is say, hey, in fact, okay, this box props is a GSL element, but it returns a GSX element. So what is this GSX element that it accept to? Okay. Because you say, hey, this is a GSX, okay, that as you can see here, they are global, namespace GSX, okay, this is a namespace of the element, alright, and React element and React component, that it say it can be is an element, or it can be an element class, and it has props, and it has children. We can recurse forever because types can be self-referenced. Let's assume it is reasonable to do a single React lazy around a single React Memo and vice versa. And HTML, holy French stuff. To do is a SVA anime element, but it's not a TypeScript lib down for now. And even that they are on construction. And this is now on construction. So GSX here, it say, hey, I'm going to export this, but this GSX element is from the React element. Or the React component. That it must contain, okay, if it is a class, it must contain is the render function. Okay, but in our case, since this is an element here, is a React React element here. All right. So it's a this one is a box prop, but from something called children. So we will need to know element children attributes, which is a children. All right. What is this children value? You know, if I get rid of this, after all, this is a GSX element. Okay. But it tells me, hey, cannot find box props. The question is that, yeah, what children is? It's a binding element children implicitly has an any type. Children. It's like we need to pass is children. Good question. Good question. What is the shape of this? I'm not sure what is the box element. Okay. Type children string or an element has no property in common type. Intrinsic attribute. So what we do here is this co-introspection. Follow the hint of the code editor and then the introspection here. So it's a type children must be a string or an element and has no property in common with type intrinsic attributes. What is this intrinsic attribute? Intrinsic. Is this a type? But it say this children, type children string or an element of array has no property in common here. Has no property in common with the type intrinsic attributes. So this must be is a string or an element. Okay, this must be a string or an element. All right, this must be a string or an element. So when I take a look at the children, you say string or element is not assignable to type React node. So we can start is okay. So by analogy, we can start with something wrong to see it is, and then type element is not assignable to a type string. You know, but type element is not assignable to type string, which means that you need is an element. You need is an element. But it say element is not assignable to type React node. You know, by doing this, so by following the hints and doing some code introspections, that's the best way to quickly find the path for. So in our case, here we're looking at this. This is the element, children, all right? Type element is not assignable to type React node. Type element is missing the following property from type React portal. But it say this element is not assignable to type React node. So if we say React node, okay, React node, now it actually saying that. All of these children that we're going to receive as props here are React nodes, okay? And it can be a React element, or a string, or a number, or a React fragment, which is an iterable. Okay, a React portal as a way to now put its elements outside of that, the normal flow. A React portal, for example, models, booleans, null and undefined. As you can see, we're getting ourselves familiar with this definition here. And we solve this issue. Of course, it's going to show something different here, which is this. And I prefer is to, you know what? That's interesting. That's very, very interesting.
Right? Describe JSX element. You can see that I get yelled at for anything that has more than one element. Right? That makes you saw before. Okay. Like JSX element was like my first go-to because before we covered a name bad, it's JSX element, right? Which is true. Except like it could be more than one. So like the syntax for an array, depending on your cursor, where your cursor is. And this blows up in a different way because it's like, cool, it can be more than one JSX element, which makes this box very happy. But you know it's not a JSX element? A string. So you can continue to play this game.
Try with a string.
Or a string. And I think it has two strings that get yelled at, but there's really no intersection there. Like these two at the bottom, I'm not even going to waste your time.
The idea here is to buy.
Those aren't even types. The correct answer here is React.React node. And I will show you
Exactly. Following the hints in your code editor. Exactly. Following the hints in your code editor.
So what I can do in this case is there's actually one built into React.
And doing some code introspection.
This would be the rest of your props. This would be like name badge props or like greeting props or whatever. And it adds, hey, this
is
have
the
that are either React node or undefined.
Is a lot of the time the best way to find your path for.
Right? Because I do get cool autocomplete here as well. You know, if you've learned anything about me right now, is that I like especially all this stuff having it filled in for me and making sure that I have like a lot of times you have cool autocomplete in there and you just rest of your props. So like other than this doesn't really take any props other than children. So what I can do in this case is there's actually one built into React called props with children, which uses the syntax we take in generic and says this would be the rest of your props. This would be like name badge props or like greeting props or whatever. And it adds, hey, this could have children that are either a React node or undefined. Right? You kind of use that as built in there and you just have fun with that. You'll get like that type of thing.
So you can use this that. So you can use this, just a React node. Okay. That's one way to solve this. Or by saying is that, hey, props with children. Or by saying, hey, props with children. Props with children. Props with children. Where it actually is what it contains is the children property. Okay, and then you can pass as the props for that.
But the thing I would love to be able to do is also like have this idea of like a style prop, right? Because I do get cool autocomplete here as well. You know, if you've learned anything about me right now, is that I like especially all this stuff having it filled in for me and making sure that I have like a lot of times it will just be strings, so I can still go rogue here. But I can like put these properties in, and maybe I want my like wrapper component to also be able to like take a style element that it passes through, but like, well, I don't really just want to say it's an object or anything along those lines. But again, you can kind of figure out like by introspecting that like React does have this type. You know, like at any point to get interested in these, you can always like command click and go through and actually like see the types. It's an experience that everyone should go through. but like over time it starts to make, it's like kind of seeing the matrix. But we can take this and we can basically say that, okay, like we do want to actually take a style tag, you know, and this is kind of useful too, like depending on how complicated your component is, like you want to pass like different styles like for the outer component, stuff like that, you can actually then be able to use this property in multiple places, right? And now this actually, that style will then have all the same typing that we eventually pass through to the child components. Okay, so we can actually say,
So by using it, for example, this, and say, hey, this is a... Okay. But if you want to actually get some auto-completion features like this, that icons thing is the style. As a CSS okay. Border. Okay. And I think it's much more better using props with children from React. So now you can have these nice little auto-completion features.
spread the rest of the properties. Not if we don't write regular JavaScript. Cool. And so I can pass those in as well. And like, because they're the same type, like TypeScript's all okay with this. Like, you're guaranteeing that this style object is okay, then I will let you use it in React's component where it's expecting that style object as well. And both of those just kind of work. So the kind of answer, again, which I have written out here, is we do want React node. The rest of these don't really work the way we think they do, and so sometimes, you know, there is a little nuance there. But the props with children is usually your answers, because it's a very, you could write that yourself, right? You hover over, you can see it's got a very simple implementation. You could take a look, you can figure it out, but it is there as a utility method for children. And I like that. I'm here for it. Cool. So as we saw, props with children. There's also, and we're going to use this a little bit later. There's component props without ref and with ref. The ref is, you know, in React 18, I think we have forwarded refs. Possibly earlier than that. And so whether or not you want to actually define that, I tend to use without ref until I know I need to pass a ref through, because I just want the simplest possible solution. But this will actually be all of the props from just a regular HTML button in this case. You can pass the name of any HTML string, and which includes children in this case too. And the cool part is you can pass them all through. Previously, you could actually, in React 17, you could say like, hey, if this is a React.component or a functional component, that children was implicitly included in there. That was there was a very long article like for the proposal and the change, explaining all the reasons why, that I am not going to like, you know, somewhat
why we use props with children
the amount of TypeScript that we definitely need to like build our apps is different from the amount that you need to build the
type
for like React or like style components and something along those lines.
for the auto-completion feature.
You know, this is like at the end of our time together, you're like, yes, I would like to.
It is auto-completion feature in React children.
Generic, where without ref thing. I was curious if there's a better way, because technically that's still like, you know, we're trying to be super type safe. Button is a string, we might make a typo. Is there like button props or something?
So this button under the hood, let's see, let's pull one out and like take a look. Let's learn it. Let's follow my own advice, right? So let's actually grab this real quick. We need to use it. So if I, you know, like it looks like it's just a string, but one of the things we're actually going to see a little bit is, and I think you pointed out this earlier, but types that can have meanings between them. So under the hood, like for instance, if I do make a typo, I get yelled at, right? And we'll actually see like a little like how this works when we make reducer actions a little bit. But if I look under the hood, you can see that component props without ref. That generic extends element type. Keep going, right? Element type, you know, tries to figure out whether it's an actual another React component or if it's one of the ones that's just an intrinsic element, HTML element, JSX. Keep going, and you can see that it's actually using the key
Here.
of just every valid HTML element. So it's got to be one of these keys. So even though it looks like a string, it is a limited set of strings that you can pass in.
Exactly. And then typing components state.
Even up until children. The other kind of like, of the two kind of core ways that React does its thing is props. What's the other one? And so, okay, so what do we do about state? So for that, we're going to switch over to another example. And so, just So again, I guess we start in a world where we have like what is mostly a React component. Let's take a look in the browser. We count the days since our last JavaScript accident. Last time undefined was not a function, or we tried to call a map on null or something along those lines. Right now it has no real state to speak of. And again, this is where we kind of double down on one of my core themes, which is when possible, TypeScript does try to stay out of your way. So we'll do like use state.
Exactly. Now it's with state.
Add a snippet. Which basically fills it in. Count for themes, which is when possible, TypeScript does try to stay out of your way. So we'll do like use state. Count.
How did you do that?
Add a snippet. Which just basically fills it in. The cool part is count.
How did you do that?
Add a snippet.
To give you dangerous.
The cool part is it will capitalize ST for me. It won't. I can figure out how to make it also auto import use state if I haven't already. But that's one extra tab. Yeah, there's a bunch of things that I can. I'm very lazy. So we've got this count, and we give it a default value of 0. And guess what? It knows a count is. It knows it's a number. It knows I'm not using it anymore, but it also knows that it's a number, right? And that's pretty cool. Now we can go ahead and find that 0. There it is. Swap it in, and cool, whatever. But the nice part is too is that we can only set it to a number. We look at actually set count as well. And some of the ceremony around this stresses you out. Don't worry about it. Use state is really a wrapper around use reducer, so that's why it's dispatching actions. It just kind of uses this like very basic action. In this case, we'll actually kind of like accidentally rewrite this a little bit later, but it's saying like, hey, we're going to dispatch an action. For set state, it's just a value really, and it's got to be a number. This way, if we do try to set the count to a string, and let me tell you where we accidentally get strings when we begin with numbers. One of my biggest pet peeves, which is input type number, the event target value is a string, right? And that's when you start adding, and then also you know that you can add two strings together and it'll concatenate them, right? And so the nice part is like you will now have to become completely aware of it, but also becoming blissfully unaware that that's a problem, because like since you can only set it to a number, if you ever accidentally take event target value, which happens to be a string, and try to use set count as if there was an form field towards the bottom here for like no reason whatsoever, right? It will immediately catch that for you.
Did you know about input value as number, or instead of doing dot value as number, which is nicer?
I just like that's better than I'm gonna do that. I'm not gonna do what I have planned here, which is like to like parse int it or whatever, inject it to the number. I'm gonna live do that as well. I'm gonna live learn about value that as number. What's the support on?
Great.
Awesome. I'm into it. See, this is why I can on here. So
I'll double check in the meantime.
All right. We'll have live updates to Mark on the support for event target value dot as number. Cool.
Yeah, it's green across the board.
Green across the board. So we've got this on click.
Clean across the board.
For event target value dot as number. Cool.
Yeah, it's green across.
Clean across the
Green
board.
across the board. So we've got
Clean across the board. Clean across the board. Oh, clean it across the board. Clean across the board. Oh, clean across the board. No, okay, it's affecting everyone. Oh my god, it's affecting everyone. Clean across the board. Okay. Clean across the board. Got there. That was quite interesting. Okay. But again, this is the way of how you can slowly but progressively is follow the okay. So follow the just and again, this is most of the time it'll be your daily day task. So we do know how others implement their types or interface, so you can by looking at the by looking at the hints that the code editor give you and doing some code introspections, a lot of the time that well, actually this one, so a lot of the times that's the quickest way to find the path for. That's interesting. That's very, very, very interesting. Okay. Holy moly. That's quite interesting. That's quite interesting. Another React component with one child, a necessary React component with two children. Exactly. A necessary React component with one, and a necessary React component with two children. Props with children. And as you can see, this prop with children, it must pass the children. Alright. Props with children, which can be a React node or undefined, or the props you're gonna pass through, the props with children. And the P is unknown, which is the genetic type of the data that you're gonna pass to this. Alright. Slowly but steady. Across the board. Okay, it affects across the board. Okay. That's quite interesting. That's quite interesting. Quite interesting, bro.
Got is on click, where like I can say that I have it, you want to say set count is count plus 1, and it can only take a number, as I said.
Yeah, but where the F do you get that accident counter reaper? Oh, that's another one. A simple counter. Okay. Now this is, first we'll look at types in components. React components. Exactly, React component with types. Typing components exercise, and then typing component children exercise. And here we're looking is that typing component state.
In the browser, we count the days since our last JavaScript accident. Last time, undefined was not a function, or we tried to call map on. You can say that when I have it, you want to say count is count plus 1, and it can only take a number, as I said. For some reason, I decide that like it won't let me set it to a string, right? So I instantly get caught because like not knowing about target value value, I have made this mistake before, right? And like yeah, I catch it pretty quickly, but it does involve me like going to the browser, like clicking a button. Like you don't really know what any of these apps look like other than those moments that I flash them on the screen, because mostly I'm getting all my feedback in the editor itself. Set state also takes a function, which I really love. And again, it knows already that this value is count. Yep.
Does it know that because you put 0 in the state?
Yep.
Exactly.
Which
It's inferring. This is because it's inferred. Set count knows that after all, okay, this is now with hooks. Set count is a function, and now it is much more explicit about this.
I think nice segue for
that it receives a callback. That is receives a callback here. That's exactly what it's doing here.
Like, what happens if I don't have a value yet, right? Or other situations, like when TypeScript can't figure stuff out for us, is when we have to step in, and we'll talk about like what those cases are and how to step in. Yeah.
Question. So you're explicitly taking count in the set count. Is it an equivalent to prevent like race conditions around previous state, kind of?
Basically. And it's also nice because like it gives me a bunch of options, right? Like, so the question was like, does this prevent a race condition? Like, if I had a fictitious count was 1, and then you know what? Let's do it 3 more times. Do you know what my new count would be? 1, right? Because closure state count was a 0, so it's like 0 plus 1.
Exactly.
Okay?
This is to prevent.
0 plus 1. Okay. Right. And like that seems inefficient. But this is not the workshop on React performance. This is on TypeScript. But yeah. So if I did this on the other hand, if I am in any way a 10x developer, it is because my multi-cursor skills are incredibly strong. So this case, it'll be like, cool, 0 plus 1 is 1, then it'll pass that value in again, and 2, right? And so the other nice part is that I could, the reason I typically use it, I'm not usually super worried about the race conditions, the reason I will use it is, it's super easy to test. Like, not having to mount an entire, at this point I have to say that's a number, because like, I've given TypeScript just no clue what's going on here. Pulling those functions out if they're a little bit more complicated than incrementing a number, this is a JavaScript function. JavaScript functions
Exactly.
are very easy to test. I put a parameter in, I look at what the return value is, and I make sure it's what I expect. So if I have like more complicated logic, I'll also use that function syntax so that I don't have to like mount a component and like fake click on things. I will just pull that out and test it like that. Cool.
But this is now looking at how exactly with state. But this is now looking at him flexing. Steve demonstrated how type state properties. By default, Typescript will infer any type and default state, typing component state.
But everything is handled for us, and life is good.
But also, now this is the exercise here.
So we've got all that in place. I can't set it to anything that it shouldn't be. So my challenge for you, and I kind of like alluded to some of the nuances here, and like Mark explained to us event.target.value as numbers. We all get to try that one out for funsies. Is we know how to type a change handler, right? We know most of how event.target.value as numbers. We all get to try that one out for funsies. Is we know how to type a change handler, right? We know most of how to handle this form, and so what we want to do is also have where they hit update the counter to a given number, that will also work.
Okay. This is what you can find is this. Use a state as an exercise. Alright. So we get an instruction to update the accident encounter. So the form update the state from both the input fields and the submission button. Okay. And clean across the board. Okay. So here's you talking about is
Also becoming blissfully unaware that that's a problem, because like since you can only set it to a number, do it. It's absolutely like other than those moments that I flash them on the screen, because mostly I'm getting all my feedback.
so typing component state. Exactly. This is the new one. So typing component states. Okay, so typing component state. Pretty much flexing how he can do this stuff easily. Okay. So setting the value in a hook or in a state in a hook will automatically make Typescript infer it is type. Okay, so things to know, things to remember, things to know, well, things to know, yeah, things to know. Avoid race conditions. Okay, avoid race conditions when triggering multiple events. Okay. Use snippets that allow you to use snippets that allow you to use use a snippet that allow you to use that allow you to set quickly hooks. Okay. Yeah, use a snippet that allow you to set quickly hooks. Avoid race condition. Use a snippet that allow you to do that. And yeah, pretty much that. And then the exercise here.
In the editor itself. Set state also takes a function, which I really love. And again, it knows already.
Exactly. And set function. So setters accept functions. Setters accept function, which is great. Setters accept function, which is great. That's right. Setters accept functions, which is great for testing.
That this value is counted. you're like setting up a nice segue for the next section. It's like, what happens if I don't have a value yet, right? Or other situations, like when TypeScript can't figure stuff out for us is TypeScript. But yeah. So if I did this on the other hand, incrementing a number, this is a Java. I will just pull that out and test it like that. Cool. But everything is handled for us. So we've got all of that in place. I can't set it to anything there shouldn't be. So my challenge for you, and I kind of like alluded to some of
the exercise instruction here is to create this component. Your mission should choose to accept is accepted. Is to update our accident counter to get that form working with our state. So is this accident counter here, which is something that we are not, that it has application on the counter here. Okay. It's one of the reasons that it's like, why you didn't include that in the codebase? Anyway, but we got the counter here. You know, we got our counter here. There, and then you say git clone of this. That's right, and the accident counter. So by looking at this and open up the code editor, open up our code here. I think you can see what I'm looking right now. No, I need to update that. Okay, no problem. Counter, the code, there you got it. You're not updated. Okie dokie. I'm going to zoom in a little bit so you can see what I'm actually doing. No, I'm not that blind. All right, and drink a little bit of water here. Okay, and then now look at this. We're calling as a counter, and it's saying, hey, we would like you to now is find React.js as runtime. Okay, this is, look at this, cannot find model, which means that you should install this. There you got it. It's going to install this. All right. All right. Interesting. Okay. And now when we look at the counter, it say, all right, I already recognize what is this, thanks to the Typescript configuration here. Okay, so here we got the sample configs. Tailwind config. It's interesting that we didn't have any ESLint, but we can add that. All right, and because this application is not focused on production, it's just a simple example here. That's one of the reasons why they don't have that. Okay, we got our index entry point here when we say, hey React, let me now grab this element at the root. Okay, and then in there I want you to now render all of these React components as it is, and they're using it in a strict mode. Interesting, they're using that in a strict mode, and in a strict mode, which means that they're using is React 18. All right, and the strict mode is say, hey, as a way to guarantee that I don't have any state, that I have stateless components, so I don't have any components that is re-rendering. They said that the problem is that the evaluation is a build time is, or a development time is twice. So to actually make sure if you don't have any hooks that are re-rendering the components for performance. Okay. All right. So our task here is to say, all right, let me now is this one. All right. And accident counter here. So this is a typing component state. Okay. So typing component state exercise. Wait, what? No, for real? There you go. So download the repo. Okay. So download the repo here. And follow the instructions. All right, and then follow the instruction here with your states and exercise as it is. All right, so we already download the repo. You're gonna take a look at the instruction here, and it's telling us if you choose to accept it, is to update. Follow me along. Is this your mission is, if you choose to accept it, it is to update our accident counter and get that from working with our state. Okay, here's what we're going to need to do. Add an additional use state hooks that store the value in the input field. Okay, let's store the value in the input field. On submit, update the value. Okay, so far so good. So on the form, it say, hey, I want you to now to add a new state here. Use a state. You can say is cons. Now let's go back to the code here. Cons. This is a hook. We're gonna say is the counter as well as set counter, which is a function here. And here we're gonna call this the use state from React. Thanks for the out import, and set that to a number. Okay. So as you can see here from the use state, okay, first is a number and then is a dispatcher. In this dispatcher, we want to now take a look at what is this. Not on the React doc. If you want to take a look now, what is this React dispatcher here? Or from the use states, exactly. Can you open this? Exactly. So on the use state, right? So from version 16, now we can make use of the context and the state, right? So it actually, as you can see, that's one of the reasons of why you can, by looking is at the code hints that provide you the code editor, and then introspect a little bit to figuring out what is this behind the scenes. Now you can look at this. This is the initial state, okay? Or it can be a function here. So it return is the state and is dispatch a function, which is this React.dispatch is a function. It won't return anything, but it's just only trigger this state behind the scenes. It's saying, hey, this is the state, and this is the this is the state. Sorry, this is the state. This is the setter, and I'm going to trigger is this when someone changes, when you call this function. That's one of the beautiful things of this. So this dispatch, exactly, is triggering is a dispatch, which a sec is a function to update that behind the scenes. You may wonder how this is working, how now React is actually keep track on all of the state. You can argue that it's using closure behind the scenes, all right, as a way to now hold all of the state in JavaScript, and then when you want to update a state to re-render a component, now what it's doing is to keep track this huge list of state. That's interesting. That's very, very, very interesting. An alternative to use state is to use reducer. It's usually preferable to use a state when you have complex state logic that involve multiple sub-values. It also leads you optimize performance for components that trigger deep update, because you can pass dispatch down instead of callbacks. Use reducer. This is part of these advanced hooks, all right? And again, an alternative to use state is use reducer, like it is. And they now also introduce that on 16, version 16. That's quite interesting. If you want to look at the version 18, no, nothing there. That's interesting. They has not added anything new to the language here, or to the framework, which is great, which is totally great. Okay, so you can see here, this now actually is returning is this is state and the dispatcher, which is a function here. So what we can do here is to say, hey, on submit, all right, prevent default. Okay, we don't want you to run that default here. Okay, and we're gonna do is this. We're gonna call the set counter here, and we're gonna see, hey, since this is now accept is the state, okay, by saying is, well, we're gonna get is the so the value in this case is something that we're going to put here, which is the counter. Okay, and when we want to update this, we want to do is something like this. So I want you to prevent this. So I don't want you to actually refresh the page, and in fact I want you to call is the set counter here. Okay, where now the event current target, which is a wrapper. Remember that after all, the E here is actually one of the great things, because it's telling you what is the shape of this form event, man. So this is a React. This is a React form event. It's a synthetic event, React form event of the form event, which must be from an HTML element. And now it's saying, hey, no, this is not a current target. It's an HTML form element. It's an HTML form element. and it tells us, well, this actually doesn't exist. The event contains is the target. Okay. The event contains is the target here. And you can hit like, hey, I want you to add something here. But you can say, hey, well, let now actually is anytime we form this, we submit this, we want is to now get our counter, okay, which initially is 0, and I want to return is the counter plus plus. Okay, remember that this actually accept is a npm star. This actually accept is a number here. So when we hit here, it doesn't update it. Oh, the counter. Okay, this is very interesting because you expect that the number will be counter plus plus.
Nuances here, and like Mark explained to us, event.target value that has numbers. We all get to try that one out for fun. Is we know how to type a change handler, right? We know.
It's like on click. Oh my god. Yeah. But remember that the thing here, okay, is to update our accident counter to get the work that from working with our state. On submit, update the value. And on submit, update the value. So how can we now on submit update the value? You may wonder. Okay. Since after all, it receives now the value, which is the counter. In our case, the counter that we're passing here. Okay. And we want now to do something with this. Okay, this is what we want to actually test this. On increment. Oh, never. It'll never trigger that, of course. Okay. But it is interesting. It's funny because it's like here's what you're going to need to an additional state. Use state hook that store the value of the input field exactly, and on submit update the value. And on submit update the value. Okay. And then you say update the counter. Okay. It's like you want to update here the counter as it is a counter, like so. And anytime you actually want to click here on click, okay, you're gonna say, hey, I want you to evaluate this, which is first you're gonna receive is the event, okay, that for our purpose, okay, for our purpose, we just want us to now increment that counter. Okay, we're gonna increment that counter.
We know most of how to handle this form, and so what we want to do is also have where they hit update the counter to a given number, that will also work. I'm submit it, so I gotta like store that separate value for a hot minute. I'll grab it down.
Exactly, because we have is this counter here, and now we say he's like, hey, I want you to now set the counter here for this. So anytime we increment that, we say, hey, -1. All right. And when it's on reset, we say, hey, on click, I want you now to, well, set counter here, and I'm going to use this as an arrow function, as a callback, by say, hey, the counter here is now counter equals 0. And doing the same, now let's going to put it here to get the feeling here. On click is that, all right, now we're going to pass is the event, but to increment that counter, setter, okay, and we say the counter here, it'll be is now the counter plus plus, right? Or you can say something like this. All right. So with this, now we were able to see that our counter is actually incrementing as expected. Call the set counter. Exactly. Where the counter on decrement, on increment is like that. That's quite interesting. It's like, return, okay. It's interesting because it's like with this, what you're saying is that first increment the value and then assign that. First increment the value or decrement the value and then assign that. And here we're going to set that to 0. So now we are finally able to do that. Increment and decrement. Of course, we are actually incrementing the updater counter. But what we can do here is this. We define as another state here. We say draft counter and set draft counter. Okay, where here we define this as another state, use state 0, where that will now evaluate that. And then it say, I want you to show is the draft counter here, and then on the form, prevent the behavior by default, and then set the draft counter here, okay, of the value that we're going to receive, which is the counter here, but I want you to now return is the counter, okay, or in our particular case, I want you to do is this. The counter that you're receiving will be is the draft counter counter like this. As it is. But you say, hey, draft counter is a const, you shouldn't reassign the value. Okay? So we can now put this as let. As a way to say, hey, this is now the new value. So we are reassigning this. So now when we hit here, we say update counter, it's supposed to update that. Set draft counter. And you need to return that. Exactly. Draft counter here, and then you say is draft counter, and the counter here, and then you return and you can return something like this, and then you can return is the draft counter, pretty much like this. So now when you do this, you reset, increment here, and then you update the counter. We need to actually is on submit, save that, set draft counter here. Okay, as a way to pass now that counter. Or you can just do something like this, which is the counter, the value that we got in the counter. Something like this. Hey, counter. Update the counter for us. So we hit update counter, type submit set draft counter. And here we are passing is the current value of the counter. Okay. And I think we need to show is the draft counter here for that. The way how do we update that is by using the set draft counter as it is, and then let's return the counter for that. Okay.
And we can start off as count, but like, unless I do something in here, like Typescript is going to make sure I don't accidentally end up in the situation where the input field bites me. So we have that in place, and do when this changes. We can do it inline, or we can pull it out. We'll just say that we want to change it to the value of this input when it changes.
Yeah, but the idea here is that.
Cool. And because it's a number, it is angry with me, right? And that's nice because like I don't want to talk to you about how many times I've made this mistake as I'm just like in the zone, because it's like I'm already resentful that I have to like do this rigmarole with React of like taking the value and I can't just bind it together like other frameworks will go for me. And so a lot of times I'm in the middle of some other thought. I'm doing this because it's a chore and I'm supposed to. And so, but it's like, hey, you accidentally passed a string in here, and that's great. Like, yes, I wish that didn't happen. So Mark taught me about dot.
Just the postfix.
It's a postfix.
Properties just value capital A.
What? And also, I believe you because autocomplete relates. Right. Also, we learned that that exists. Do we all know about this one? The add state. Mark's absolutely.
Value as number.
And now it is a piece of me, which is pretty great. Otherwise I could keep it as a string and then do this somewhere else as well. Is that just on? Oh, it's just event target value as number. That's pretty cool. The other thing I would do is just keep it as a string and then convert it to a number when I needed to. But now I don't need to do that. Awesome. And then so like we have that on change, and then really there is the on submit, which is just going to take. And I know that everything is working as it should because like I didn't get yelled at, which is a general rule for life that I follow, that we can do also. Now, what if we wanted to say that like when that input field changes, let's validate that any of this works before I get a little too overzealous.
No, because the value that you're exactly.
Yep, there we go. when I'm focusing on the TypeScript stuff, sometimes I forget to think about just the regular JavaScript, regular how things work in code. Awesome, say 15. And this is why you live code with all of your friends.
The button doesn't have a listener. So.
Oh yeah, because
Exactly.
form is happen. I don't want it. You can't submit it, or you can. I don't think. What I want is that to happen in the form itself.
Mm-hmm.
To begin with, was to make my life easier for when we did this together. Cool. Now, if I wanted this number to then update the input field, I only increment the decrement, but only going down, and I wired it wrong. Which, to be clear, as someone who rehearses all this stuff, I'm to the point where I've rehearsed it wrong so many times that now I do it wrong. Because I think about increment, reset, and then decrement, but the buttons are in the opposite order. But now I have like literally just done. I've rehearsed that so many times that now it is what I do. So that's a learned thing about me. Awesome. Now, do we need to say that when we change the regular count, we want to update the field as well? We don't. I just need an excuse to use a use effect hook to show you one little gotcha that might come up. With use effect, there's lots of gotchas. Let me clarify. One TypeScript gotcha that might come up with use effect. Use effect is just basically like, would you like a foot gun? Cool. And so we'll give it a function that says whenever count changes, we also want to update the draft count. And the only kind of real place that TypeScript and use effect interact, and there's a lot of times like a set timeout as well, and it's like just kind of JavaScript fanciness these days, which is then set draft count. Count. Everything's great. Everything works. Good. The only place you will get yelled at is if you're like, I'm going to be fancy and I don't like curly braces. And this actually, because this returns void, if you had something that returned an actual value here, it's like, because normally if it returns, it's expecting a function returned or undefined, and so if we said like, even, let's return the count, right, you get yelled at because it has to be undefined. So just make sure, like, if you ever see that you get confused, it is because it's expecting either a deconstructed function or undefined, and it will yell at you about it. That is just it will happen to you once in the next year. You will get bitten by it. Hopefully this sticks in your brain. I have saved you a good 10 minutes. Like, I'm going to be fancy and I don't like curly braces. Let's see. And this actually, because this returns void, if you had something that returns an actual value here, it's like...
But it's because the idea of this piece of code is like, you are completely messed, bro. So the idea of this code is to actually set that counter. Yeah, it's like you're a mess, bro. You get is this, you're incrementing and decremented, okay, and then you hit update counter is like that. We just submit. This must call this and set the draft counter here. Okay. Let's set that counter to the counter. Right. And there you go. So the point of this, and that's to me quite interesting, that it didn't actually update that as expected. Okay. Even though that I'm passing is that. Exactly. So now this is actually work as expected, but as a number here. And update counter. That's what it is. So now with this, we were able to see how now can we make use of the types here, all right, and how we can get the data out of an input by saying on change. Here we're going to receive is a function where now this function, the event.target.value as number and as date. And I think this is beautiful. As date and as number. That's lovely. So the beautiful thing of this is that now actually is, well, React with TypeScript help you to autocomplete features that you need to. But remember, the idea of, or the recap of the entire video here, the recap of this entire video here is the way to follow me along here. So the idea reason of looking at how can we now use React in TypeScript here is because to look at what are the benefits with the value proposition of TypeScript, which is make it easy to type your React components and debug your app without leaving the text editors. Okay, that's the value proposition of this, you know, and make sure that you get the current props in your component as you expected. So by understanding is now the value proposition of doing this, which is the two aspects of this course, which is first, what is the TypeScript? Understanding the philosophical aspect of TypeScript, and second, how you don't need to get out of the editor and jump into the browser as a way to look what's going on. By looking at the hints in your code editors and do some code introspection, you can now, a lot of the time, figuring out your path forward. And that's the value proposition of this. So we first look at the in components, so TypeScript in components, a little bit of the TypeScript speech, sales speech, to say, okay, TypeScript is good because it allows us to prevent errors at runtime, and you know that happen at build time. Okay, also it allows us to build large build code bases in a maintainable way, because now you have all of these guardrails around your code and how you can use your React code, or how you can use your code. In the autocomplete feature provided by the code editor. That's beautiful. Then we look at how can we do is now the components. All right. So how can we now look at TypeScript with components, TypeScript with props, the difference between types and interface. So for example, interface, if a code base actually follow types or interface, you do that, follow that along. The idea here is that with types, with interface, is that is for public APIs that allow your consumer to extend if they need to. And with type, consider in the case of React, to make sure that you are receiving is the right props and state by having all of this guardrail. So again, the subtle difference between the implement is that you can use extend as a way to now access to the property method or inherit, whereas with type we use is the, for example, ampersand sign to say, hey, I want you to now extend the functionality or extend the shape of this new type that I'm creating. That's interesting. Okay. All right. That to me was quite wild. And how by following this convention with your React component is by always defining your types in the file initially, and then you're gonna do a refactor to put it there on the file, in a single file. And then by looking at now at the component props, okay, which is now TypeScript with components and the TypeScript with props, exactly, TypeScript with component, types with children components, and TypeScript with props and a state. Now it makes a lot of sense of what we are doing here. Okay, and that'll be all for this video. Take care. Bye-bye.